Excel has functions for finding the cumulative distribution for a standard normal distribution or any regular normal distribution. So let's start with the standard normal distribution. The function for it, norm.s.dist, and with two parameters, z and cumulative. Z will be the value where you want to find the cumulative distribution. That is for distribution from negative infinity up to this point, z. And cumulative is another parameter for you to indicate whether you want cumulative distribution from this function or not. If you use a value 1, that means you want cumulative distribution. Right? If you use 0, it'll give you the density of this function at this point. So we want 1, right? We want the cumulative distribution. So for instance, in this situation, we want to find the cumulative distribution at 2 for standard normal distribution. So for this, we will use a norm.s.dis with z value 2, and then cumulative we say value 1. So if you enter this function inside Excel worksheet, you will get the value. Right? So this second parameter, you can use a value 1 and 0, or use English letter true or false, right, for indicating whether you want cumulative. So here is an Excel worksheet, and we want to find a cumulative distribution at 2, right? So this, in this cell, I'm going to type equal to norm dot. Actually, they'll give you a selection of function. Just click on this, and the first parameter is the value you want the cumulative distribution. You want cumulative distribution up to 2, and then comma and 1 indicating whether you want a cumulative or not. Right? So enter that and hit enter. You get the cumulative probability or cumulative distribution in a standard normal distribution up to 2. Okay. Now, if instead you want the distribution above 2, right? That's a complement of this. So in order to do that, I can use equal 1 subtract the cumulative distribution up to 2. So cumulative distribution up to 2 is norm dot s. Actually, I'm going to use this hint to help. Double click on it, it'll bring up the whole thing, and then 2 comma 1. That's 1 subtract the cumulative distribution at 2. Right? That will give you distribution above 2 in this standard normal distribution situation. Now, if you wish to find a distribution in between 2 points, like negative 2.3 up to 2, then you can find a cumulative distribution at 2 and subtract the cumulative distribution at negative 2.3. You will get the actual distribution in between the two. Okay. So to do that, I start with equal. Anytime you use Excel to enter a formula, you start with equal. And then with norm and s, and we have 2 and 1. That's the cumulative distribution at 2 minus norm dot, and we're going to use that function again, negative 2.3 and comma 1. So this will give me the cumulative distribution at 2, and also cumulative distribution at negative 2.3. So the cumulative distribution at 2 subtract the cumulative distribution at negative 2.3 will give me the actual distribution in between these 2 points. And that's 0.9665, right? You can do this problem by actually figure out this one first and use another cell to figure out this one next, and then find a difference. That's another way to do it, right? But to quickly do this, I can just put those two functions in one expression. That is, again, equal to the cumulative distribution at 2 minus the cumulative distribution at 2.3. And here is a picture of it. We wish to find the distribution from negative 2.3 to positive 2. We will find the cumulative distribution up to 2 minus cumulative distribution up to negative 2.3. The difference of these two will be the distribution that you're looking for, right? And you can achieve that by using this Excel function. Okay. And as I said, you can do this problem by actually figuring out the cumulative distribution separately and find a difference. That is okay too, right? Now, if you wish to figure out actually the distribution below negative 2.3, of course, using the result from this function, you get that. That is 0.0107. That's a cumulative distribution at negative 2.3, right? The total distribution in this standard normal distribution that is below negative 2.3. Now, what if I need the distribution above 2? You will use a complementation rule, right? We know the distribution below 2 is 0.9772. So 1 minus that, you give you the area above 2. That's 0.0228. For a normal distribution, but non-standard normal, you have a mean and standard deviation. There's also an Excel function that can help you to find the cumulative distribution at any point in this distribution. Okay. So that function is this norm.dist. With the first value, that is this value where you want to find the cumulative distribution. And the second parameter is the mean of the distribution, and third is the standard deviation. And the last one, of course, is the indicator of whether you want a cumulative distribution or not. I have this normal distribution that has a mean 100 and standard deviation 15. And I wish to find the total distribution between 90 to 120 in this normal distribution. Now, Excel has a norm.dist function that allows you to find the cumulative distribution, right? And so you can use that to help you to solve this problem, right? So I use a norm.dist, and the first parameter is the actual value. Second and third parameters, they are the mean and standard deviation of this normal distribution. And the last parameter is cumulative again, right? So the difference between this and standard normal is the standard normal, you know the mean and standard deviation, so you don't have to specify it. But for any regular normal distribution, you will specify mean and standard deviation. So let's do this. So you have cumulative distribution 90 to 120. We find the cumulative distribution 120 first. So that's equal norm.dist. Okay. And then you specify the value 120 and specify the mean 100. That's the second parameter. The third parameter is 15. The standard deviation, the last one is 1, standing for cumulative, right? And use that to subtract the cumulative distribution at 90. So specify 90 first, comma, the mean, the standard deviation, comma, and 1 again. And the difference of that is around 66%. Okay. So with that, use it in an application. For instance, this one, the distribution of weight of a population is normal with a mean 120 and standard deviation 15. You want to find a proportion of this distribution that is between 100 and 130. Well, then you know the mean and standard deviation. You can get these parameters, right? You know the endpoint 100 and also the 130. So you have 130 here and then 100 here. You can get the cumulative distribution at both endpoint, and then you can get this problem solved.